All right, so today we'll take a look at our last section for this week, which is 1.2, and we'll start part of 1.3, but we're not going to be able to finish that until next time. So the first thing that they mention in 1.2 is just kind of a general approach to solving problems, okay, like word problems, or it would apply to really solving any kind of problem. So it's probably some things you already do or know how to do, but we'll just kind of go through it quick. So anytime you're given a problem, first thing you always want to do when you read it is figure out, okay, what are they telling me in the problem, and what are they asking me to find? Because if you can't figure out what you're supposed to find, then you're not going to have any idea of what kind of formula you should use or even what approach you should use. So always figure out, what are they telling me, and what are they asking me to figure out? The next thing you want to do is figure out what way you want to solve the problem. Okay, for some problems, drawing a picture is extremely helpful. Okay, a lot of times when we get to problems involving trigonometry, say you're standing 50 feet from a building that's 112 feet high, what would be the angle if you were looking from the ground to the top of the building? Very helpful to draw a picture of that and visualize what's opposite from what's adjacent to what. Okay. Sometimes making a list is helpful. Let's say you were trying to list different combinations of food you could have for lunch. And for lunch, you had 3 choices of a drink and 2 different meal options. So maybe you could get water, soda, or coffee, 3 different drinks, and then for your sandwich option, they had like ham and turkey sandwich. What are all the different combinations of lunches you could have? Well, there's not too many that you could list them all out. With only 3 drinks and 2 meal options, there would only be 6 possibilities, combinations of lunch. If I asked you to tell me how many different license plates are there in the state of Massachusetts, okay, and I give you a criteria, like say the first 2 spaces are letters and the last 4 are digits. You don't want to make a list. There's just way, way too many. So a list isn't always practical. Okay, sometimes we do more than one of these things. Like a lot of times once you have a picture, then you can set up an equation using your picture. But setting up an equation at some point is usually part of the problem, and pictures can help you to get to that point. In page 13 in your book, they got a bunch of different suggestions for techniques for problem solving. Okay, so after you figure out what do they want me to find, what are they telling me, and you have an idea of how you're going to approach it, then you actually carry out your plan. Okay, if you're going to draw a picture, okay, now start drawing your picture. And then maybe if you're drawing a picture of a triangle, you're going to use Pythagorean theorem and solve that equation at some point. It's just kind of some very, very general suggestions. And as we go through some problems today, I'll ask you which one of these methods or another method is helpful for what we're trying to solve. All right, so this one says a company charges $15 to rent a car. That's a flat fee, you pay one time. And then they charge you 20 cents for every mile you drive the car. Now, if we're going to set up an equation to model the situation, how many unknowns are there? Or can anybody tell me what would be a potential variable in this equation? Yep, Sam?
How many miles you drive?
Okay, so how many miles you drive the car. And there's also one other thing that will then determine. Yep, Jayan?
The total cost.
The total cost. So we're going to need 2 variables. We'll let one of them be x and one be y. Usually we let the independent variable be x. The dependent variable is y. Can anybody tell me which of those two things is dependent here? Is it the amount of miles or the cost?
The cost.
Exactly. The cost depends on, cost is dependent on how many miles you drive. How many miles you drive isn't dependent on cost. If you rent a car and you have to get somewhere, well, you got to drive the amount of distance you got to drive, right? And whatever it costs, that's what it costs. Okay, so cost is dependent on miles. And why do you think I might use X and Y? Where do you think I might be going with this kind of problem eventually? Because technically I could use A and B or anything, but X and Y kind of lends itself to maybe doing something in a little bit. Rebecca?
A graph.
Yeah, maybe we'll graph this and then figure something out from the graph. We can either graph by hand or on the calculator. Great. So anyone think they can give me an equation using X and Y to represent the situation above? Yep, Anna?
Y equals X times 0.20 plus 15.
Yeah, X times, that's 0.20 plus 15. Did anybody switch the order of X and 0.20? Yep, that's fine too. If you wrote 0.20x, looking at that 0.20 as like a coefficient, that's also fine. The bottom one is more in y equals mx plus b form, but the top one is perfectly fine. Okay, so there's our equation to model the situation. To just write the equation, we didn't really need a picture. Okay, this wasn't a real visual problem. Okay, so now we're going to use our model to find the cost to drive 50 miles. So Dylan, if I want to drive 50 miles, what letter would that be plugged in for, the X or the Y?
For the X?
Yeah, for the X. So we get Y equals 0.20 and fill in 50 miles for X plus 15. So 0.20, I think of that in my head, 0.2 is a fraction, it's 1/5. So what's 1/5 of 50 and then plus 15? How much?
10 and then 25.
10 plus 15, which gives me 25. Remember, that was a cost, $25. Okay, same idea to do it for 100 miles. Now, if you go 50 miles and it costs 25, can I say 100 miles will cost 50? Double the distance, double the cost. Why not? Why doesn't that work? Sam?
It's only 25 because we add the 15, so it'll be a different amount to add the 15 to.
Right, we don't want to double the 15. If you double 25 the way I just said, it's like you're doubling that 15 as well. So really the only part of the cost that's double is the mileage part, not the initial 15 part. All right. So sometimes you might think, oh, quick shortcut in your head and do something like that. It might be a little more complicated than this kind of problem, but you try to do a shortcut like that and it doesn't end up working out. Okay, so what's the cost to drive 100 miles? Yep, Jane?
35.
Yeah, it's going to be 20. 0.2 times 100 is 20 plus 15. $35. Okay, so that's an example where you're plugging in for the independent variable and finding the dependent variable. Okay, that equation that we wrote earlier, that's called an algebraic representation of the problem. If you just showed this to somebody, they would have no idea that it's about paying $15 for a rental car plus 20 cents per mile. It's just an equation with a slope and a y-intercept. So the algebraic representation of a problem takes away all the context of it. The fact it's about a car and all that stuff. Just reduces the whole problem to a pure equation. Okay, so if you see that in the homework, find an algebraic representation for the situation. Basically, they just mean write an equation. Sometimes the book words things a little funny, okay? And I can't, there's some things I can't remember every single thing that the book is going to mention. But you might read it and be like, that's worded kind of awkwardly. But then when I explain what they're asking for, then it becomes a lot easier. So I'll try to remember to explain as much as I can about how the book will word things. Okay, what's a little different about that one? It says, Sarah was charged $50 for renting the car. How many miles did she drive? What's different here? Yep, Eddie?
Value and asking you for the X.
Yeah, they're giving you the y value, and they're asking you for how many miles. What's the x? So we're going to take the equation we just had, except fill in for y. All right, and the way we're going to do this one, we're going to do it two different ways. I'm going to show you how to do it algebraically, which is kind of what Abby was just saying, plug in for y. So let's do that first. Y equals 0.20x plus 15. So I'm going to divide by 0.2 and 0.2. Actually, whoops, that's wrong. I'm going to subtract 15 first. I'm already thinking of my next step. So subtract your 15 and you're going to get 35. And now dividing by 0.2, that's dividing by 1/5. What's dividing by 1/5 the same as doing? Leo?
Multiply by 5.
It's the same as multiplying by 5. Okay, so if you take 35 and multiply by 5, what do you got?
175.
175. Now we always want to remember, what did we just solve for? We solved for x. If we have to, we can go back and look at it. But that's 175 miles. Now that's the algebraic way to solve it. Any questions on that approach? Okay, let's try a different way, which is more of a graphing approach. Okay, so I'm going to show you a few things that I haven't shown you yet on the calculator. Now, even doing it graphically, there's a couple ways we could do it. For now, I think I'm just going to show you one way. Can anyone think how you could solve this problem graphically? Forget using a calculator, like if you wanted to do it on paper. How could you do this? It's like basically like solving a system of equations. Yeah?
Because the original equation is y equals mx plus b, we can graph it out onto a xy plane and then find when y is 50 was x.
Yeah. So let's start by, once we turn it on, okay, you press y equals, and I'm going to type in 0.2x, 0.22x, there you go, plus 15. And I want to know where that graph is going to hit 50. Okay, that's the question. When does that hit 50? So 50 is being plugged in for what letter? The y. So all you have to do is put another equation. You want to know when the y value equals 50. Calculator is a little strange. Okay. So I type that in, And now I'm going to hit graph. What's wrong? We talked a little bit about this yesterday. Yeah?
Is it too far?
Yeah, I don't have the right zoom. I'm trying to hit where y equals 50. And if I'm on a standard window, look how high my x value is going. It's only up to 10. So I'm going to set things a little higher, and I'm going to set some things a little more common sense. X is miles. Do I need to worry about negative miles? No. So 0 is the smallest number of miles we could have. X max is how many miles we're going to drive. I don't know the answer to the problem. I'm just going to put 60. Put in 60 for X max. Now, Y is the cost, negative cost. Does that make sense? Nope. So we don't have to worry about negative cost. And then Y max, it has to go to at least to 50. But if I put it at 50, then it's going to be right on the edge of the screen. So I'm going to put it at 75. And I'm going to hit graph. So there's my line for cost. And I'm better, but I still can't see where these lines intersect. So what needs to be set higher? I don't think my y value needs to go any higher. What needs to go higher?
Your X max.
My x max. I didn't put it high enough. So let's try x max maybe 200. I probably don't even need to go that high, but it's going to just, it'll be good enough. Okay, so now I've graphed both of them. And what am I going to try to find on that screen? What do I want to know? Yeah?
Where the 2 points meet.
I want to know where those two lines are going to intersect. So there's a feature on the calculator that can do that automatically. Does anybody already know where it is? Yeah?
Under second trace.
Yeah. Second trace, okay.
Go down to 5.
And go to the fifth option down, which is intersect. And the way intersect works is you have to, like if you had multiple graphs on the screen, you have to tell it which two you want to use. We only have 2 on the screen, so there's not much of a choice. So I'm going to say I want you to use the blue curve and the red curve. It calls it a curve because it doesn't have to be a line. It can be any shape. And then the guess, in this case, is not overly important. Okay? Where the guess becomes important is if you have multiple intersections. Like if you had a parabola, a line could go through it twice. When you do intersect, it'll give you the intersection that's closest to the guess. Okay? Again, in this case, there's only 1, so you can really put the guess anywhere you want. And hit enter, and then it tells us the intersect. So it says X is 175 miles. Okay, so that's exactly the same answer we got doing it algebraically. That's just doing it graphically. Hey, any questions on how to do that on the calculator? Basically, how to calculate an intersect. Okay. So that's one new thing that for today, for at least for some people, if you didn't know how to do an intersect. Okay. Another direction you're going to see in the book a lot, it's going to say find a complete graph or find a complete viewing rectangle. What complete means is you find a window that shows everything that's important about the graph. Okay, and I know that's a little bit vague, but it's not exact, like how you do this. And there is no one answer. I would say for the problem we just did, that is a good viewing window. It's not the only one, but it shows the intersection point. The first viewing window that I had, it was not a complete graph because the intersection point I needed was off the screen. So when they ask you to find a complete graph, okay, all you have to do is write down 4 things that are in the window. Tell me what you used for x min, x max, y min, y max. Just write down those 4 values. Okay. Any questions on what it means to find a complete graph? Okay. Let's try an example. This might be one we actually looked at yesterday. They want me to graph y equals x squared plus 10 and find a complete graph. Okay. Now what I generally do is I'll clear out everything we already typed in and I'll do zoom 6. Okay. I'll start with a standard zoom. Okay. Well, actually, you know what? If you didn't already clear it, let's start with the zoom we have. X squared plus 10. Is that a good viewing window for that graph? It's the same viewing window I had in the last problem. Jan, what do you think? What's wrong with that?
Well, since it's x squared, it's a parabola.
Can you tell that from the graph? No. That's an awful picture of a parabola. You can't even see the other half of it. And you're zoomed out so far, to me, that almost looks like a straight line. So I'm going to go zoom 6, go back to the standard window, and see if that looks any better. Okay, does that look better? If you don't have a graph on the screen, now you definitely don't have a complete graph. What do you think I need to adjust? I think I can just adjust one of those 4 values, and I'll be all set. How about Trevor? Which one do you think I need to adjust? X max? Well, we could try it. Let's try making it 20 and see what happens. So now we're looking further to the right. So I do like the idea of adjusting a maximum, but not that one. But I do want to adjust the maximum. Yep? Yeah, let's adjust the y max. You could leave the x max like that, I guess. That's okay. Let's put the y max on 25. I mean, you could probably get away with 20, 30, 40. Any of those would work. That's a good graph. Now I can see it's a parabola. I can see the symmetry. That's a good window. So I'm just going to take and copy my window down. Okay, and again, that one was, can't read it, but it was a -10. So just write down those 2 and those 2. Okay, so the graph we just did, a couple people already mentioned it. That was a parabola. And basically, it was a parabola where A was 1, B was 0, and C was 10. So it was x squared plus 10. When you start putting in other values for B, then we can change all kinds of things and characteristics of the parabola. Okay, if we put negatives in here in certain places, we can flip the parabola as well. And that's also the general form of a quadratic equation. Okay, does everyone have up to parabola? Okay. let's try this one. So it's a square root, and it's y equals square root of x plus 20. I'm going to clear that out. If I haven't shown you how to get to square root, that's a second function. Press second, and then the x squared, and you should get a square root. And we're just going to type in x plus 20. Big difference if the plus 20 is under the root or outside the root. I'm doing it under the root. And I'm going to hit zoom 6. What does that look like, kind of? At least on my viewing window. Leo?
Just a linear function.
Looks linear. Well, I can tell you the only things that are linear are things that are like y equals mx plus b, or something of that form or rearranged. Square root functions are not linear. Square root functions are supposed to look something like that. Part of them might look linear, but they actually curve. They never level off, but they slowly keep curving upward. So square root function should always have a starting point. And that starting point, if you don't shift it up or down, is always on the x-axis. So given those hints, which value do you think I need to adjust here? Yeah? Well, if we adjust x max, what's going to happen is we're going to just see further to the right. We're still not going to be able to see where this thing is starting from. Maybe you can see it's a little more curved. I'm not sure. It's kind of hard to tell that it's curved. But I think if I put a line that's next to it, you can kind of see that there is a little bit of a curve. But still, we're not really seeing that curve real good yet. Yep?
Need to move the x min.
Yeah, let's adjust the x min. Let's try negative 20. I hit the wrong thing. If you want to stop it from graphing, you can, I think if you press second, I forget if it's quit or off, but if you do one of those things, if it's going to take like 30 seconds to finish your graph, you can stop it. So let's put that at negative 20. And now that's a good graph. Okay, I could even go a little more if you want to see further to the left, but there's nothing more to see. The graph is starting at negative 20 and curving to the right. Okay, so that's a good complete graph. Okay, so I would just copy down my 4 values: x min, x max, y min, y max. Any questions on that one? Okay, and as we study functions, you'll get more familiar with what they should look like, so you kind of have an idea in your head what you're looking for, and if you don't see that on the screen, then you know you need to adjust it. I can copy those over. Okay, another thing we can do with the calculator that can come in handy sometimes is we can actually graph individual points. Okay, so sometimes you might have like data if you did an experiment and you want to graph the points and see if there's a pattern, or maybe you'd want to put the points in and have the calculator calculate a pattern. The calculator can do that too. So I'll put this, what I'll do is I'll try to make it a little smaller. And I'm going to show you how you can type in points into the calculator. Okay, so to type in these points, the first thing we're going to do is press Stat and go to Edit. So Stat is right below the delete key. And again, that'll all be in the video too, so if you want to leave space and fill in the steps later, or try to fill it in and watch me at the same time, you can do that. So you press Stat, and Edit is already highlighted, so I'm just going to hit Enter. Okay. Now, when you do that, you might already have stuff in there. Let's say the last person that used it left some numbers in there. There's a couple ways to get rid of them, but easiest is just highlight the number, press delete, press delete. Don't highlight the list and press delete, because if you press delete right now, I'm going to wipe out L1, and then I have to try to reset the calculator and get it back. So was everyone able to get to a screen where at least L1 and L2 are blank? Technically, I could use any of these, but the simplest way to do it, I'm just going to put the X's in L1, and I'm going to type my Y's in L2. Okay, so I'm going to do all my X's first. -3, -2, -1, 0, 1, 2, 3. Then I'm going to press the right arrow. That's going to get me over to L2. And I'm going to type all my L2 values. -18, -2, 2, 0, -2, 218. Okay, so I've put in all my ordered pairs that I want to graph. Any questions on that? Now, if I go to graph right now, I haven't actually told the calculator to graph these points. I've typed them in, but I've got to tell the calculator to do it. Okay, so what I'm going to do is I'm just going to quit. I'm going to get out of that screen I'm in right now. So I'll just go second quit. It's all saved. And now I'm going to go and press my Y equals button, like I'm going to do a graph. But I'm going to go up to the top where it says plot 1, 2, and 3. I'm going to hit my up arrow. And I'm going to turn on plot 1. Now, if your calculator is, hasn't been changed, what that's going to do, I'll press second stat plot just to show you something. I've turned on plot 1, and it's going to get the X's from list 1, and it's going to get the Y's from list 2. Now, if somebody went in the calculator and changed that, they could change the X list to be L3. And then what I'm about to show you wouldn't work, because we didn't type anything in L3. So hopefully everybody's is set with the X's as L1 and the Y's as L2. If you want to double check, you just press second Y equals, and it should say L1, L2. Any ones that doesn't say L1, L2? Yep.
Mine says L3, L4.
So what you can do is you click on plot 1, and then you've got to go down there, and to get an L1 you press second and then the 1 key. Did that work?
Yep.
Yep. And then in L2, L3, 4, 5, 6. They're all second functions right there. All right, so I'm going to go back to Y equals. I've turned on plot 1. I'm going to get rid of anything else that's in there because I don't want to graph the square root function. And now we have to set our window. So I'm looking at my X values. I'm going to go a little beyond -3 and 3. I'm going to go -5 to 5, because I don't like it right on the edge of the screen. And how about for my y values? What would be two good numbers that wouldn't be right on the edge of the screen? Yeah,
Negative 20 and 20.
yeah, I would go -20 and 20. And then when you hit graph, those are the coordinates we just typed in. Now it doesn't draw a line through them because it's not a graph, it's just data points. Any questions on that? Yep.
Is there a way to tell the calculator to draw a line through the data points?
Yes. So I'm not gonna get into it too much. I'm gonna tell you that this is the answer to your question. It's x cubed minus 3x, but the calculator could tell you that. What I'm gonna do is I'm gonna type that in just to save time. X cubed minus 3x. You have to use the arrow to get out of the exponent, otherwise the cubed, the minus, the 3, and the x would all be in the exponent, and I don't want that. So if I graph that, it should trace right through those data points perfectly. That is the equation for how I generated those points. But yes, the calculator could figure that out for you. And that's the real advantage of what we just did. Plugging in data and having the calculator find a pattern to it. So then you could make predictions based on your model. Any questions on that? Okay. All right, so the last thing we're going to look at is the first part of section 1.3, which is only a couple slides on. About 4 slides. And then we'll be done. So in that rent-a-car example we did, the very first problem about paying 20 cents a mile and $15 to rent a car, I called x and y independent and dependent variables, which is what they're called. But there's also other names for x's and y's. And a lot of times we use some of these names when we start talking about functions. So you can also call the x variable the domain. And if you do that, you usually call the y variable the range. You can also call x the input and y the output. So x is what you plug in, y is the answer you get out. Okay, so all just synonyms for what you can call the x variable and the y variable. Now, specifically, that problem is a function, that equation. Does anybody remember what a function is in math? Not all equations are functions. Does anyone remember what makes something a function? If you want to think of it visually, there's a certain test that it has to pass. Does anybody remember the name of the test that a picture has to pass to be a function? Has to do with a type of line. Yeah? Yeah, a function has to pass the vertical line test, which basically means, algebraically, every x value has only one y value. Every input has only one output. I can show you visually an example where that's not true very easily. If you plug in 2 for x, you get an answer up here, some y value. and you get an answer down there. Okay, when x is 2, y can be two different values. That's not a function. Every x value has to have exactly one y value. Okay? And a lot of times in Algebra 1, they call it the vertical line test. So if a vertical line can be drawn through your graph and it hits it twice, that's not a function. If a vertical line doesn't hit it twice, it only hits it once, it is a function. That's another way to say it. That's how the book words it. I would just go with the first way I wrote it. Just worry about that part right there. Okay, so we kind of mentioned this earlier, domain and range, but I want to stress the point that not every function, you're not allowed to plug every single number into every single function. For example, this. If you're dealing with real numbers, what values of x are you allowed to take the square root of? Yeah, Sam?
Constants.
That covers most of them. There's one more you can include in that.
0.
0. So in this problem, square root of x, the domain is all non-negative numbers, or positive numbers and 0. You're not allowed to plug in -8 for the domain if you're dealing with real numbers. Okay, so there's a restriction on the domain. So some functions have restrictions on domain, some don't. What would be a restriction on the domain of that function? Yep, Sam?
You can't put 0 there.
Can't plug in 0. Okay, that's a little different. There's only one number you're not allowed to plug into this one. There's infinite numbers you're not allowed to plug in for the square root of x. Okay, this just has one number, 0. Okay, so domain, anything you are allowed that's valid to plug in. The range, what kind of answers do you get? Out. What are your y values? Okay, unless otherwise stated, I just mentioned this, the domain is a real number. Two different notations for functions. You can use y equals notation or this other notation. Does anyone know how you pronounce that one? The f parenthesis x, you don't say it like that, but yeah, Abby? F of x. Okay, so you'll see both notations throughout the year. Any questions on either of those notations for writing a function? Okay. So let's find a complete graph of that and see if we can write down the domain and range. So from the last square root problem, we know that it should have some kind of curve to it. Oh, let's see what we can do. Does everyone have what's on the left? Before I even graph it, well, what I should do is I'm going to turn off plot 1 because I don't want to keep seeing those points on the screen forever. So I'm just going to go up, I'm going to highlight plot 1, I'm going to shut it off. So now I'm not going to see those points. And I'm going to get rid of that graph. Does anybody see what numbers you're allowed to plug in for x? Keep in mind, you never want what's under the root to be negative. So what could we plug in, Sam?
Everything above 2.
Well, could you plug in 2.5?
Oh, no.
So we want to think decimals too. If you were thinking like integers, it would be a little different. But yeah, we want to think decimals too. Yep. Leo?
Anything greater than or equal to 3?
Yeah, anything greater than or equal to 3. Okay, you can't do 0, you can't do 1, you can't do 2.7, you can't do 2.9, but you can do 3 and up. So I'm going to keep that in mind when I set my window. So in my window, I can start my min at 0. I won't see anything there, but that's okay. How high can I go? Well, what's the highest number you're allowed to plug in for x? I mean, could you take the square root of 1,000 minus 3? What do you think? Yeah, Julie Nat.
You said greater than or equal to 3, right?
Yes, anything greater than or equal to 3. So is 1,000 minus 3 fit in that? Yes, x could be 1,000, x could be 1,000,000. X can go as high as you want in this problem. You only need to go so high to get a good picture. And now when you take a square root, this symbol means only the positive answer. If you have this symbol, then they want both. So because they put that symbol there, I know that my answers are always going to be positive. So my domain in this problem is any number from 3 to infinity. So the way we can write that is 2 ways. You could just say x is greater than or equal to 3. Or you can say it like this. I'm going to write it as an interval. Okay, I'm going to write it from 3, and the bracket means to include 3. If I put a parenthesis, it means not to include it. So I can go from 3, including that number, up to infinity. And I can never reach infinity, so I put a parenthesis on it. That's called interval notation. We're going to talk more about that later on. Now my range. What's the lowest y value that I ever get in that picture? Yeah?
0.
0? And how high is it going to go? It's going to keep going infinitely high, very slowly, but it's still going to keep going up and up and up and up on the y-axis. So the y values go from 0 and up, including 0. Okay, so that's when they ask you to find domain and range. That's the kind of thing they're looking for. I'm going to hold off on that one, but keeping in mind that it's a parabola. Do parabolas go up forever and down forever? No. So when you're writing the range of a parabola, it's one of two cases. Either there's a minimum value and it goes up forever, or the other way around. There's some maximum value and it goes down forever. Okay. How about left and right? Will a parabola continue to go left and right forever? Yeah, there's never a point where the walls of a parabola become straight. They're always, even if it's very, very slowly, they're always still going out. Okay, so when you're looking at the domain for a parabola, you can square any value you want for x. Positives, negatives, fractions, decimals, 0. But just be careful with the range. Okay? It doesn't go up and down forever. Let's graph this one just because I haven't shown you how to type in absolute value. If you want to graph absolute value, it's under math. Then you have to go over to number. So press your right arrow to number, and it's the first option, ABS. And now it puts in the absolute value bars for you. So math, go over to number, and it's the first option. Okay. I'm going to do zoom 6 just so you can see what this looks like. It's a parabola that wants to go negative, but it can't because you put absolute values around it. Okay. What this parabola really wants to do is go like this. This section that's in blue wants to kind of flip down, but it can't because of the absolute values. So when you look at the range of this one, to me it looks like it goes from 0 up to infinity. It's going to go from 0 up forever. How about the domain? Is the graph going to continue to go left and right forever? That's the x-axis. Yeah. You can, and another way to think of it is you can square any number you want. You can plug anything in for x from negative infinity to infinity. But the answer that you get is not negative infinity to infinity. It's only from 0 and up. Okay. All right. Let's see what this is. Oh, so evaluating a function. So basically, sometimes they'll give you something to plug in for x in this notation. All you have to do if they give you a value to plug in is replace the value, take the value they give you, and plug it in for x, and do out the calculation. So for example, if they wanted to know f of negative 2 in that problem, just fill negative 2 in for x. That's what that question is asking. So it would be something like this. Negative 2 squared plus 1. And what is negative 2 squared plus 1? Yeah, 5. Now you want me to plug in 3. Change x to 3. So now it's 3 squared plus 1, which is 10. Now, if you want me to do the last one, okay, it says to plug in x minus 3, square it, and add 1. How do you do x minus 3 squared? Sometimes people have a word they use to remember how to do it. Dylan, you remember how to do that out?
You would just do x minus 3 times x minus 3, but I'm not sure. You're talking about what it's called.
Yeah, it's a double distributive, or some people use the word FOIL. I don't know if you've heard that term before. So again, in pre-cal, I'm assuming you can figure out how to do that. It would be x squared minus 6x plus 10 when you combine all your like terms. Okay, and that's what you get. So when they ask you to evaluate, you're just plugging in whatever they give you and doing out the calculation. And actually, this I already mentioned to you earlier. That's last time. So I said to you, not every equation is a function. And if you want to think of it visually, in order to be a function, you have to pass the vertical line test. Okay, so the vertical line test states if a vertical line hits the graph more than once, it is not a function. So circle. If you drew a circle, is that a function? No. Vertical line hits a circle more than once. How about a parabola? Would a vertical line ever hit a parabola more than once? No. A horizontal line would. But no matter where you put a vertical line, never hits the parabola more than once. Okay. Hits more than once, not a function. And that's it. Okay, so the homework, on page 20, there's the problems we talked about with a little bit of graphing on the calculator and finding an intersect. So sometimes, if it's strictly a calculator problem, you can just write on your notes, on calculator, if there's nothing to show. Okay, so on page 20, it's 1 through 10, 18, 21, 29, 32, 38. And then on page 30, there's a lot of looking at pictures and just saying, is it a function? Yes, no, that kind of stuff. Okay, so it's page 30, 1 through 8, 11, 13, 16 through 19, and 24. Okay, I'll check that next time we have class, which isn't until September 11th. That's the next time we have class.